This question has a big fraction and it wants us to take the derivative and then plug in 2. So it's a derivative practice problem. So let's take a look. So first thing, excuse me, I'm going to do is make that x to the half and that x to the half. Because remember, square roots are x to the half part. It's just easier to do the derivative rules. Okay, so we're going to take the derivative. Now remember, this is two functions divided. So we have to follow the dividing rule called the quotient rule, which means they take turns, right? You can't just say, I'm gonna do the derivative of the top, do the derivative of the bottom, done. No, no, no. Yeah, that special way. Remember, I'll write it over here. F over G derivative. You have to do the first one first, the second one sits there, minus the first one sits there, the second one's turn over the denominator squared. Remember that? So here we go. The derivative is, so the first one goes first, take the derivative of this one. What's that going to be? That's going to be a half x to the minus, right? The half comes down. Subtract 1. A half take away 1 is negative half. The 5 just goes to 0. Got him. Times the second one, unchanged, minus. And then it's the first one unchanged, x to the half minus 5. Times, now it's the second one's turn to take the derivative, and he also, the half will come down. It'll be a half x to the minus half as well, over the denominator squared. So that'll be x to the half plus 5 squared. That good so far. So they took turns. So the top one went first, got his derivative, second one just sat there, minus. Then the first one just sat there and it took the derivative of the second one over the denominator squared. Okay, now we got to clean that up a little bit. So how do we do that? It's a little ugly, isn't it? What should I do? Should I do? Should I do? Um, well, I'm thinking about my options here. Yeah, this is where calculus gets a little tricky. You just have to do a bunch of these and then you can see a trick. So I'm going to show you something and you're going to be like, I just didn't see that. It's like a trick. It's you do a million of these and you see it. See how this is the same? They both have the same thing. See how there's two here? Yeah, here's how I'm looking. This is one term, subtract a second term. Terms are things separated by adding and subtracting. So that's how you should be visualizing it. This is one term on the top and a second term, and they both have something in common. So you know what we're going to do? Factor it out. Okay, and then I'll put a big old parenthesis, and then that leaves x to the half plus 5 minus x to the half minus 5. Sorry, my 5s don't look so good. Bottom hasn't changed. X to the half plus 5 squared. Do you see what I just did there? This half, this red, half x minus half, that could go boom and boom, and it would be right back to this term and that term, right? See how I looked up here and said one, two terms separated by the minus, they both have a common piece, take it to the front. Now, at this point, can we cancel those or just cancel this and one of those powers? No, none of that because it's subtracted. Remember, we can only cancel a big important rule to make it through calculus. You can only cancel multiplied items, not added, subtracted items, right? So I can't be canceling this right now with this or anything because he's an add subtracted item. All right. So what are we going to do then? Well, basically, um, I'm going to, let's do, okay, Here, let me show you about these parentheses. So right in here, I'm going to take this x to the half. So I mean, this minus is going to distribute minus x to the half plus 5, like that. And then on the bottom, x to the half plus 5 squared. What am I going to do with this? I'll leave the half from this x to the minus, I'll let it go down to the bottom. It's x to the half. You don't have to, but negative powers can jump to the bottom like that. You know that rule, right? And so where are we at now? Now we got a half times these guys cancel. 5 and 5 is 10 over x to the half. X to the half is 5 squared. And that's basically it. We could just do one more thing, I guess. Half of 10 is 5. And so x to the half and x to the half plus 5 squared. So there's, oh, just happened. There's our first answer. That's what they had. They just made x to the half back into square root x. That's fine either way, totally fine. See that? So you can make that roots of x or leave it the way we have it. Yeah, if it bugs you, you can go back and make those roots. It doesn't matter. It's good either way. This is a root of x. This is a root of x. Whatever. It's good either way. X to the half. The computer will take it either way. They're both good. Okay, now that's part one. Then part two, plug in a two, huh? Just plug in a two. So we'll go, okay. And that'll be the wrap here. F prime of two. Plug in a two to this. So it is clear there. So we're going to have 5 over square root of 2 times square root of 2 plus 5 squared. And then just go to Desmos and type it in. And you'll get that number right there. All right, so what did we do then? We did the recapping here real quick. We did the quotient rule. It's the quotient rule because it's two functions of x divided. When you have quotient means divided. So you have two of them, but you can't just do the top, do the bottom. No, that's illegal. That works for adding, subtracting. If you have two functions of x added or subtracted, yeah, you just do the first, do the second. But if you have two functions of x multiplied or divided, multiplied, you have the product rule, divided, you have the quotient rule. They're basically very similar rules. They basically say take turns. Do the top one first, let the second one just sit there, minus, then let the first one just sit there, and then do the second one over the denominator squared. But then we had a lot of simplification, didn't we? Here was the biggest trick, as I looked at this term and this term. Terms are separated by minuses. I said, oh, look, they both have this piece in common. I factored it out. See, it could distribute and it go back. It'd be back to the same. And then I just distributed in there. These canceled. I let this negative power jump down there. And then these canceled. So we said 10, half of 10 is 5. And there we go. And then we plug in. So that's how we do it.